Good afternoon. So today also very poor strength. So it seems to the students are not involving, not participating. They are not interested in the classes. So you are wasting of our times. Right. So yesterday we discussed about the group 4A elements: carbon, silicon, germanium, tin, lead. We discussed the electronic configuration, and also we discussed about the 4A group elements are belongs to which group, which block elements. Okay, and the outermost electronic configuration, general electronic configuration is NS2, NP2. These are belongs to the P block elements, and also the oxidation, stable oxidation state of the 4A group elements is the +4 as well as the -4 also. That means the 4th group elements can lose the 4 electrons and also can gain the 4 electrons. They are losing as well as the gaining. That's why the carbon is having of the tetravalence nature. The carbon is tetravalence nature is there, so that you are getting of that one. And in this carbons, the 4th group elements, if you are observed that one, carbon and silicon are non-metals, and germanium is metalloid. Metalloid means which can act as a metal as well as the non-metal. That is called as a metalloid. So germanium is which is used in the semiconductors. Semiconductor for preparation of the semiconductors, germanium, silicon, germanium, these are the used in that one. And the tin and lead are pure metals. Okay. Now the occurrence, discuss the occurrence. Carbon is the 2 types of occurrence will be there in the crystalline form and amorphous form. Crystalline form is nothing but the diamond and graphite, and amorphous form is you are having of the so many type, that is a powder form. So there is a lampblack, charcoal, coke. Okay, that is, those are the powder form is there. And silica, silicon is occurred by means of when the silica is reacted with the carbon. Silica means SiO2, that is a sand. Sand is reacted with the carbon, that means pure carbon. We are reacted, we are getting of silicon, Si, and the carbon monoxide is released. Okay, that is for getting of the occurrence of the silicon. And lead, from the galena you can prepare the lead also by means of oxidation of the galena. You are getting of the lead, that is a preparation will be there. And you are discussed about the hydrates. Hydrates means carbon can form the carbohydrate, that is a particularly alkanes. Silica is also, silicon also, hydrates are silanes. Like that, we are having of the germanes and also tinanes and also there is a plumbanes. These are the all type of hydrates are formed. But the carbohydrates are very wide range of carbohydrates are there. That's why as the alkanes, there is a organic chemistry we are keeping, because the carbon can showing of the catenation property. What do you mean by the catenation property? Catenation means self linkage among themselves, which can form the straight chain, branched chain, double bond, triple bond, and also cyclic nature. These are all are possible by the carbon atom. That is called as a catenation property. Due to of the catenation property, carbon, that means hydrocarbon, alkanes are getting of the number of compounds. So little bit catenation property is also present in the silicon, but among the 120 elements in the periodic table, only the highest catenation property is showing of the element is only carbon. Little amount will be the catenation showing by the silicon also. Okay, so next you are discussing about the oxides. Oxides are the monoxides and dioxides, and that's why we are discussing monoxides means carbon monoxide. When incomplete combustion of the carbon, we are getting of the carbon monoxide. Carbon monoxide is a neutral gas. It is a very dangerous one. Why? Because it is a primary air pollutant. Carbon monoxide is a primary air pollutant, which we inhale by the anybody. That means deoxyhemoglobin is present by the human beings. We are getting of the faintness. So incomplete combustion of the carbon, you are getting of carbon monoxide. And similar way, the silica, silicon oxide prepared by the silica plus silicon. Silica plus silicon, when you are using up the at high temperature, that means sand plus silicon, you are getting up. Sand plus silica, when heated at about 1300 degrees Celsius, we are getting off silicon oxide, silicon monoxide. But silicon monoxide is unstable. Again, it can form the silica only, silicon dioxide only. So the dioxides are, carbon is completely burning, you are getting off carbon dioxide. And silica, that particularly silica is silicon oxide, that means silicon monoxide is immediately formation of silicon dioxide and silicon. Silicon dioxide and carbon dioxide both are acidic in nature. Please remember, this is the carbon monoxide is a neutral one, and silicon dioxide and also carbon dioxide both are acidic in nature. In our examination, it will be an important point. Silicon dioxide and carbon dioxide. See, in this acidic nature, their particular two compound does not having of hydrogen atom. Proton does not is present. Proton is not, nitrogen is not present, even though they can act as acidic in nature. Here we are discussing the carbon dioxide is acidic nature and silicon dioxide is also acidic. But carbon dioxide is a gas state and silicon dioxide is solid state. Why? The reason is the at room temperature. Why these act as? Because of carbon dioxide at room temperature, it is a discrete molecule, linear structure. The carbon dioxide is a linear structure, means this is having of the double bond between the carbon and oxygen. So a linear structure is present. But the silicon dioxide is tetrahedral manner. That means it is linked with the 4 oxygen atoms. This is a linkage will be there. Okay, like that again silicon and oxygen. This is the presence of this one. Or you can say okay, this is a tetrahedral structure will be taken silica dioxide. It is in solid. Why? Because the silica is surrounded by the 4 carbon atoms. The silicon is surrounded by the 4 carbon atoms in tetrahedral manner. Due to that, silicon dioxide at room temperature is in solid state. That's why carbon dioxide is a gas and silicon dioxide is a solid. But solid carbon dioxide is called as, the question is, solid carbon dioxide is called as dry ice. Please remember, this is a question they may ask. The solid carbon dioxide is called as a dry ice, which is used in the refrigerator as a refrigerant, which is present in this particular case. Okay, these are the dioxide which are used in the regular purpose. Now you are using of the carbides. So next classification is the our carbides. Carbides are means they are metals. That means carbides are classified into 3 categories. Next, carbides. I'm classifying of 3 categories of the carbides: ionic carbides, and covalent carbide, and metallic carbide. This metallic carbide also called as interstitial carbides, also metallic carbide. So what are the ionic carbides? That means their movement ionic nature will be there, the carbide. The ionic carbide examples are, we are having of aluminum carbide, okay, and also calcium carbide, magnesium carbide, like that. So many are the carbides, ionic carbide. Aluminum carbide, you are using of the aluminum carbide, that means Al4C3, calcium carbide, magnesium carbide, Mg2C2, okay, magnesium carbide, and beryllium carbide. These are the all the carbides, the examples of ionic carbides. So see, aluminum carbide, when hydrolysis, you will be getting off methane. When the calcium carbide hydrolysis, you are getting off acetylene gas. When the magnesium carbide on hydrolysis, where you are getting off the propane. So magnesium carbide will getting off the propane, C3H4. Propane is formed. So during of the hydrolysis, you are getting off this one. Remaining there means that is a compounds we are getting off the whatever the different compounds where aluminum carbide means aluminum hydroxide is liberated of This is calcium hydroxide is liberated, magnesium hydroxide is. The major is the methane. This is the acetylene. This is the propane. When the magnesium carbide is under hydrolysis. This is an example of in the examination. Suppose if it is a 10 marks question, classify the carbohydrates. That is a carbide means you are getting of this particularly binary carbides are there. This particularly these are classified into ionic carbides, covalent carbides, and metallic carbides. Ionic carbides are the examples are at least you have to give the 2 or 3 examples: aluminum carbide, calcium carbide, magnesium carbide at least. Okay, why? Because the aluminum carbide in the very first hydrocarbons alkane series, the preparation of alkanes, you are using this one, alkane aluminum, and the calcium carbide in the alkyne series. The next lesson is there. You can use the calcium carbide, and also this is used the calcium carbide. I already told that the calcium carbide is used for the ripening of the fruits, artificial ripening of the fruits. So calcium carbide is used. Whatever the raw mango immediately turns to the yellowness within the 1 day. This is a artificial ripening of the fruits. That is the calcium carbide. But the government is banned the calcium carbide, even though you are getting of the calcium carbide by the China, you are using of the calcium carbide for the ripening of the fruits. This is a very dangerous. Coming to the why? Because ethylene gas is released. This ethylene gas is released. Actually, the fruit is ripened means we are getting of the fructose only. The fructose is not there in our fruit. Ethylene gas is there. That is ethylene gas is there. That is harmful to our body. So be aware of the calcium carbide fruits. That is main important, the banana and the particularly mango. And coming to the magnesium carbide, which is the hydrolysis, you are getting of propane. So these are the examples of ionic carbide. Coming to the our covalent carbide. Covalent carbide is only boron carbide, B4C, and silicon carbide. These are the 2 examples of covalent carbide. Boron carbide and silicon carbide is comes under the covalent carbides. The covalent means sharing, mutual sharing of the elements we are getting in the carbide form. Now coming to the metallic carbide. The metallic carbide is very strong bonds that is present in tungsten carbide, WC. This is a tungsten carbide, which is used in the metallic nature. Why? Because the tungsten carbide is so hard. This is used for the making of the cutting of the tools. But you have to cut the tools. For that purpose, tungsten carbide is used. It is a very, very hard metal. Hard nature will be there. That is the metallic carbide is there. It is used for the cutting of the tools. These are the carbides which are used from in this particular case. And here, see the calcium carbide or silicon carbide we are using in the covalent nature. That will be getting of this one. This is about the carbides. Now coming to the next is the carbonyls. What are the carbonyls which are present in the 4th group element? Why? Because the carbonyls are so very important in the 4th group elements. The carbonyls means what? The central atom is linked with the CO. Central atom, whatever the central atom is there, some M. MCO, that is the central atom. M is a metal. And the carbonyl group is present. That is having of this carbonyl group. These carbonyls are, you are having of monocarbonyls, binuclear carbon, metal carbonyl, bicarbonyls are there. What are the monocarbonyls? We'll see the monocarbonyls. First of all, the carbonyls under the monocarbonyls. Mono means the central atom, only one metal ion is there. That is called as a monocarbonyl. I will give the list of the monocarbonyls in that list, compulsory question. But monocarbonyls are nickel tetracarbonyl. This is called as a nickel tetracarbonyl. What is the structure of the nickel tetracarbonyl? Means it is a tetrahedral structure. Nickel tetracarbonyl. The IUPAC name of this particular carbonyl is tetracarbonyl. Nickelate. We can use this IUPAC name. Tetracarbonyl nickelate. Why? Because the carbonyl is a neutral compound. It's a neutral. Already there's a neutral compound. It is a zero oxidation state. So that the tetracarbonyl nickelate. It is a IUPAC name. The common name is nickel tetracarbonyl. It is the structure is tetrahedral structure. And the second you are having of the second is the iron. That means pentacarbonyl ferrate. Pentacarbonyl ferrate. That is a or ferrous pentacarbonyl, ferrous pentacarbonyl. This is the main important here is trigonal bipyramidal. The structure is trigonal bipyramidal. This is important. The structure, they will ask the structure. What is give the formula. They give the formula. They will ask what is the structure of this particular monocarbonyl compound. It is a trigonal bipyramidal. Okay. This is a trigonal bipyramidal structure is there. Nickel tetracarbonyl is a tetrahedral structure is. Next third is you are having of hexacarbonyl chromate. Hexacarbonyl chromate. It is an octahedral structure. See student, I am using of only the repeated questions from the examination point of view. I am using of that one. Okay, please go through that one. I'm only, so you can think that whatever the class, those are all are important questions only. Only that only I can explaining and elaborating the clearly for your examination purpose. So important.
Excuse me, sir.
My lesson is itself is important. Whatever the topics I covered in that, okay, that is a important one. So here you are using of tetracarbon and nickelate tetrahedral structure. If you see the question papers, all the question papers from the 2015-18 onwards, so these are the repeated questions. Sorry, somebody's sorry.
In carbonyl, third one is octahedral.
Yes.
But it is having 6, no, sir?
Yes. It is depending on the carbonyl groups. Chromium is the central atom, mama. That chromium central atom is arranged by the 6 carbonyl atoms in the manner of in the surrounding of the octahedral nature.
Okay.
Even the octa means you can think about the 8 atoms. Okay.
Yes, sir.
Why? Because the carbonyl compounds are self-linkage among themselves now. So it is surrounded by the octahedral nature. Nature is octahedral. Tetrahedral is the carbon atom you are seeing. Eight, you are thinking about how it is getting off octa means remaining the carbonyl compounds may not be present, but it is the octahedral state. Okay.
Okay, sir. Okay, sir. Thank you.
These are the monocarbonyls. Coming to the binuclear bicarbonyls. Coming to the bicarbonyls, so many are in the bicarbonyls, but they won't ask the structure of that one. But I am listing of the bicarbonyl. Bicarbonyl means 2 central atoms are there. Manganese 2. And the carbonyls are, you are having of CO12. This is carbonyl compounds are, this is a 12 are there, and the 2 are the central atoms. Means each central atom is surrounded by the 6 carbonyls. Like that. Ferrous carbonyl 9 only, and the next compound is cobalt carbonyl. Why I am giving this list means one time the ask the identify which is the monocarbonyl, which is the bicarbonyl. So your identification, how to get the identification easily by means of seeing of this one. Monocarbonyl means central atom is only 1. Bicarbonyl means central atom is 2 is there. Leave over the carbonyl compounds. How many are there? The substitutions are. Why? Because depending on this one, 4 is there, tetrahedral, 5 is there, trigonal bipyramidal, 6 is there, that is a octahedral nature, not hexagonal ring structure, it is octahedral only. So depending on bicarbonyl means central atoms are 2 are there. Don't mind about the carbonyl groups. Central atoms are 2. Metals are present, those are called as bicarbonyls. Okay, so the carbonyls are only 2 categories, monocarbonyls as well as the bicarbonyls. Okay, now coming to the next topic is silicates. Silicates are also very important. We are having of how the silicates, that means we are having of the only silicates will be classified on the basis of this SiO4 minus, that is it is a tetrahedral structure. These are the units are present. How many number of units are repeated in that one? This SiO4 minus 2 is a tetrahedral structure. It is a tetrahedral. So in that units, the number of units, depending on the number of units, it is the silicates are classified into the different category. This silicate tetrahedral means it is undergoing of sp3 hybridization. Definitely we are getting off the sp3 hybridization. Now the silicates are classified into, you are having of the pyrosilicates, chain silicates, cyclic silicates, and sheet silicates. Sheet silicates means it is called as a geolites. Okay. Now, I mean, in the examination point of view, this you have to remember the what is the silicate. Silicates means that it is a units of SiO4 units is there. The number of units are repeated. The repeated unit must be, it is a one single unit. These units will be repeated in that. So that is called as a silicates. In that first silicate is called as a pyrosilicates. What is pyrosilicates means? Very simple. There is a only two tetrahedral, that is two SiO4 units are there. Two SiO4 units. How they are arranged means, I will show this one. Okay, it is again the link one. It is again one. Okay, this is called as a pyrosilicates. These pyrosilicates are tetrahedrally, but this means two tetrahedral bond. This is a one tetrahedral bond. This is a another tetrahedral bond joined together in with the one oxygen. This oxygen is main important here. This is bonded with this particular. It is again, it's a chain linkage, but I am using the one that particularly. This is called as a pyrosilicates. Next second is we are having of the chain linkages. That means chain silicates. How the chain silicates are formed? I try to represent the chain link silicates. This is that one. Okay, this is a sorry here Si. This is a bonded with this one. This is a again the one bond is present. This is a linked with one silicate units. This silicate unit is a one. Another one I'm using of another Si. Okay, this is another silicate. The writing very easy. For just to you have to use the practice purpose. This is, it is called as chain. It is repeating units. 1 unit, 2 unit, 3 unit. I'm only 3 units are repeating. So many number of units. It is a chain silicate. See here, only 2 silicate units are combined with the one oxygen. That is called as a pyro. If the chain linkage, number of silicate units are going on, it is called as a chain silicate. Now coming to the third cyclic silicate. Cyclic silicate. Cyclic nature will be there. In the cyclic silicate, you are having of only 3 units. Just like here 2 units, in the cyclic units, 3 units are present. Those are arranged like this. If you are having of this particular thing, Si, it is linked with this one. Okay, this is a 1, and here this is linked with the Si. Okay, this is a one more, and this one again. This is a Si. So it will be automatically linked with the see. It is actually, what is the structure? You can see. Is a trigonal pyramidal. This is called as a cyclic nature. The 3 units are in cyclic form. So this cyclic form is called as a cyclosilicates. I hope you can got this particular. This is a 1 unit of silicate. This 1 unit, it is a 1 more unit. So it is arranged in the cyclic form. That's why it is called as a cyclosilicate. The next 4th example of silicate is sheet silicates. Sheet-like structure. In the sheet-like structure, the example of sheet-like structure is zeolites. It is a big molecule, a giant molecule. 3 oxygen atoms for silicon is bridged one. Bridging takes place. Is a big molecule, a giant molecule is present. The example is a gelate. These are about the silicates. So silicates are arranged with the SiO4 units. SiO4 is a tetrahedral structure, is undergoing of sp3 hybridization. Those, if you have 2 SiO4 units are linked one, those are called as a pyro. If the SiO4 units are arranged in the chain structure, it's called a chain silicate. If 3 SiO4 units are arranged in the cyclic form, those are called as cyclic silicate. And the sheet means it is a sheet-like structure, a big molecule, a giant molecule. That means this is arranged like that. You can arrange. It is also arranged like this. The number of SiO4, n number of SiO4 units are present. Those are called as a sheet-like silicates. Okay, this is about the. If the examination, sometimes actually in the regular point of view, they will ask the for 10 marks question. For your sim purpose, they are asking only 5 marks question. Either it may be carbonyls, or it may be a carbides, or it may be a silicates. Next is the classification is silicones. Silicones also formed by the silica. Here also silica. The way because silica is also less tendency to showing of the catenation property. Just like the carbon is showing the catenation property, a large hydrocarbons are producing. Similar manner, similar small amount of the catenation property is exhibiting by the silica. They are exhibiting, that means silicates, silanes, and silicones are formed. These silicones are very important. Why? Because used for the silicones are silicone oils are very highly stable one, very high temperature, used in the non-volatile nature. While the using of that one on strong heating, the silicones which are used for the greases, that means high temperature purpose, that means heavy industry purpose, heavy mechanics, those are using of silicons which are used for this particular silicates. So in this particularly, you are having of, there is no long question is there, but sometimes they will ask the carbides is a long question. Similar way, you are using of the, what is the important is the, why the carbon dioxide is a gas and silica is a solid at room temperature. Explain it. And the next is the classification of carbides and classification of the silicates. The silicates classification is pyro, chain, and also cyclic, and also sheet-like structures. Sheet silicates. You can classify it. Give the simple diagrams. Why? Because sheet silicate I can't draw. It gives a big 3-dimensional structure. 3D structure will be there. It is in your book. It is clearly mentioned as. And silicones means these are the silicones which are used for the very silicone oil. That means very high temperature. It is a resistor for the high temperature. Due to of the high temperature resistant power is there, that is used as a grease or oils were particularly in the industry's purpose. So this is about the silicones are used. Next, we will go to the 5th group elements. So friends, up to now 2 groups are only over in this block. Third year, in the third year, you are having of the only the major important long question is the preparation of the diborane, properties of the diborane, structure of diborane. Okay, this is an important long question. And the short bits are so many are there. And coming to the 4th, that is the 4th year group elements. Only the thing is the short bits are the, what is the electronic configuration and how the remaining things are there. And the important is the only the why the carbon dioxide is the gas and why the silicon dioxide is the solid in nature at room temperature. And the classification, monoxides, dioxides are there. Even though you are getting off the monoxide, dioxides, we are getting off, then the carbides and silicates and silanes, and also that is the important bits will be appears in your examination point of view. Now coming to the 5th year group elements which are used for the what purpose we are using. What is the 5th year group elements? How they are classified in the inorganic parts. If you observe the 5th year group elements, what are the 5th year group elements? Nitrogen, okay, nitrogen, phosphorus, arsenic, antimony, bismuth. Nitrogen, phosphorus, arsenic, antimony, bismuth. These are belongs to the 5th year group element. So the 5th year group element, nitrogen. Nitrogen is the 7th element in the periodic table. If you want the phosphorus atomic number, means I already told that add 8. We are getting off 15 is the phosphorus atomic number. If you want arsenic atomic number, means add 18. So 15 plus 18, 33. If you want the antimony stibline, this is the antimony, which is again add the 18, means it is nothing but 51. Next stannous, after the stannous, it is a antimony. Next bismuth is a 83 element, adding of 32 number. 51 plus 32, we are getting of 83. Okay, these are the elements which are present in the 50A group element. Nitrogen is the 7th element in the periodic table. When you are writing the electronic configuration, 1s2, 2s2, 2p3. 2p3 means p orbital is off-fieldly present. That's why nitrogen is a very stable element. It is a diatomic nature. Nitrogen is a diatomic nature, N2 only. Remaining element phosphorus, arsenic, antimony is the tetraatomic in nature. Please remember phosphorus, arsenic, antimony, bismuth, which are present in the tetraatomic. P4, ES4, SB4, Bi4. Sorry, bismuth is not like that. Nitrogen is divalent. These are present. Now you are using of this particularly 1s2, 2s2, 2p6, 3s2, 3p3. Like that, 4s2, 4p3. Antimony, 5s2, 5p3. Bismuth, 6s2, 6p3. These are the electronic configuration. Fill in the blanks. Don't use the fill. You are putting of the blanks only. You have to fill it. Now this is the electronic configuration. While you writing of the electronic configuration, you are observing of the last valency electrons. These are the valency electrons. Okay. How many number of valency electrons are there? 5. 5 valency electrons are there. So the 5 valency electrons are present in the 50th group element. What is the valency of the 50th group element? It is nothing but the, you are having 8 minus group number. The valency is 8 minus, or you can say the group number minus 8, means the 5 minus 8, it is a minus 3. Yes, nitrogen is a minus 3. It is a 3 electrons can lose. That means it will be gaining of that one. It requiring of 3 more electrons to getting of stable electronic configuration. It does not lose this one. They gain the electron. The gaining of the electron to getting of the stable electronic configuration. Why? Because 5 electron losing is very difficult, but gaining of the 3 electrons is very easy. So that the 50th group elements almost all they gain the electrons, 3 electrons. That's why you are getting of minus 3. The balance is the 3 only. Valence is 3. You are showing up the minus means indicating of gaining of electrons. So the oxidation state is the plus 3 only. The oxidation state you are getting of the minus 3 plus 3. You are getting off like the confusion, but remember that how many number of gaining or losing depending on the oxidation state you are remember. And the valence state also this is a group number minus 8. It is a principle you are using. So group number is a 5 and minus means it is a minus 3. Okay, these are all are 50th group elements. The last electron is present P. No, so it is a P block elements. It is a under the P group. Okay, P block element. And also general electronic configuration is NS2 NP3. It is a very important general electronic configuration is NS2 NP3, and these are belongs to the P block element. And nitrogen is diatomic. These are all are tetraatomic nature. How the tetraatomic is? If is diatomic means there is nitrogen, there is a double bond is present between the nitrogen and nitrogen. It is a diatomic nature. And the phosphorus, if you see the phosphorus, this phosphorus is a tetraatomic nature. We are having of the tetraatomic nature will be like this. You can use as the phosphorus. This is the phosphorus. The phosphorus 3, 4. This fourth one is a linked like this. This one. It is a bond is there between that one, like the arsenate and antimony also. The phosphorus. It is a just like this structure will be present particularly P4 and AS4 and like this. Okay, this is about the introduction of 58 group elements. In this, already I told that this particularly very important of nitrogen is very stable one. It is having of off-field orbital. P orbital is only off-field. Off-field orbital, the electron is losing means very difficult. You're getting off more amount of energy, require the more amount of energy. Off-field orbital or full-field orbital. So nitrogen having off-field orbital. That's why the ionization potential value is more than the compared with the phosphorus. Or you can say compare with the oxygen also when you're talking about the period. Now coming to the fifth grade group of hydrides. What are the hydrides are? Possible hydrides are there. It can form hydrides of N3, that means NH3 ammonia, phosphine, PH3. Please remember this is the name of phosphine. It is a poisonous gas. Phosphine is a poisonous gas. Arsine. So nitrogen, phosphorus, arsenic means arsine. This is called as a arsine. Next is antimony. This antimony is called as stibline. We are using of this particularly stibline. Bismuthine. Okay, these are the types of the hydrates. Plus here only the thing is you have to remember this one where already this is, you know that this is called as ammonia actually. Okay, it is ammonia, but phosphine is a gas. Which is a gas, is a poisonous gas. Is a formula is phosphine is a PH3 is called as a phosphine. Okay, so friends, here hydrates are not that much of, it can form the hydrates, but the hydrates are this type of trihydrates, that is NH3, PH3, ASS3, SBH3, BiH3. These are the type of the hydrates are present. Okay, in that the phosphine is a important one. Next we will go to the oxides. What type of oxides are there? All the elements can form the tri and pentoxides. All the elements can form trioxides, pentoxide, except bismuth. Bismuth does not form the pentoxides. Only trioxides are formed. Bismuth does not, because of the valence state of the bismuth is +1. The stable oxidation state of the bismuth is +1 is very important one. Due to that reason, the bismuth does not phosphating a pentoxide. Remaining oxides are, you are using of the dimeric nature. Nitrogen is having of the only monomeric nature. Pentoxides and trioxides are, apart from the nitrogen, arsenic, antimony, antimony, bismuth. This nitrogen, trioxides, pentoxides are monomeric nature, only monomeric nature. Phosphorus, arsenic, antimony, they can form trioxides as well as the penta. It is our monomeric, they are dimeric in nature. Bismuth only can form trioxide, not pentoxides, due to of the inert fair effect. It is called as the inert fair effect. Bismuth does not form pentoxides. Why? Because of inert fair effect, does not form pentoxides. Due to inert fair effect. Inert fair effect means does not participate in a chemical reaction. That is called as the inert fair effect, because of the +1 oxidation state is possible for the bismuth. That is much is not there in our portion, but better to remember nitrogens are mono, oxides are there. That means mono nature, monoatomic nature will be there. This tripentaoxide is dimeric nature is there. Bismuth only can form the trioxides. And in this, apart from this one, the nitrogen is having of the so many number of oxides are there. That is NOx types. These oxides of the nitrogens are NOx. What are the NOx? You can say as nitric acid. I'm writing the names of this one, nitric acid. Okay, N2O, nitrous acid, and NO2, nitrogen dioxide. Nitrogen dioxide. It can also represent as N2O4 also. N2O4 also you can represent. So oxides of the nitrogen, variety of the oxides of nitrogen is there, except remaining other won't get the one. They are getting of the tri and penta, but oxides of the nitrogen, they are forming of nitric acid, nitrous acid, nitrogen dioxide, and nitrogen N2O3 trioxide, nitrogen trioxide, and N2O5 nitrogen pentoxide. All are monomeric nature. I'm using generally they are using of tripentaoxides. Okay, all are forming of the trioxides and pentoxide. Nitrogen is monoatomic nature, that means monomeric nature. Phosphorus, arsenic, antimony is dimeric nature. Bismuth only can form the trioxide. But coming to the nitrogen, nitrogen is having not only the tripenta, they can having of mono. Nitric acid, NO is a nitric acid. Okay, and the N2O is called as a nitrous acid. This is also called as nitrous acid, also called as, already I told in the first sem, nitrous acid is called as laughing gas. Please remember, this is the laughing gas. In an examination, they will ask, that means hysteria, a patient is a mentally retarded person, is laughing more and more because of the producing of the nitrous acid is more in the body. That's why you are getting of this one. The nitrous acid is nothing but it is called as a laughing gas. Nitrogen dioxide, this is a N2O4, or it is a dimeric form. Actually, it is a dimeric form. Remaining all are monomeric form. Nitrogen trioxide, nitrogen pentoxide. These are the oxides that is present in the particularly nitrogen. Now coming to the oxy acids of the nitrogen. For the 5 marks question, it is also sometimes it asks the questions. The main important is the nitrous acid. It is called as a laughing gas. I will list out the oxy acids of the nitrogen. It is very important oxy acids. Oxy acids of nitrogen. What are the, how many types of the oxy acids are there? I will give the structure and the formula. Hyponitrous acid. Hyponitrous acid. Hyponitrous acid means it is the formula is H2N2O2. Nothing but HNO. I'm using of the dimeric form. H2N2O4 is getting off that one. That is a hyponitrous acid. This is the molecular formula. MF I'm using. Now I'm using of structural formula. How is the structure? This is a compound name. So the compound name is the hyponitrous acid. Molecular formula is H2N2O2. This particular H2N2O2 structural formula is HON double bond and why? Because it's a diatomic nature and OH. See, 2 hydrogens, 2 oxygens, 2 hydrogen, 2 nitrogen. Very simple structural formula. Very important examination point of view. Oxy acids of the nitrogen. Please remember this oxy acids of the nitrogen. The first member is hyponitrous acid. Next, second member is nitrous acid. Nitrous acid. Nitrous acid means this is particularly the formula is HNO2. HNO2 only, this is having of the structure is having of nitrogen double bond and one hydroxy group is present. This is called as a nitrous acid. Next, third is a nitric acid. What is the formula of nitric acid? Already you are familiar with the nitric acid, HNO3. HNO3 is a nitric acid. The nitric acid formula, the structural formula of nitric acid is similar to the nitrous acid, but they are having of a single bond. This is a negative ion. Nitrous acid, one more oxygen is present. It is in the negative sign will be there. This is a double bond is linked with the nitrogen and one hydroxy group is there. This is called as a nitric acid. The next fourth one is the four are present of oxy acids of that one. Next is pernitric acid. Pernitric acid. This is called as HNO4. Please remember here HNO, HNO2, HNO3, HNO4, nothing but. We are using of HNO. Why? It is a already 222 is there. If you are getting off cancel HNO, HNO2, HNO3, HNO4. For easy to remember in the examination point of view. HNO is there, HNO2 is there, HNO3 is there, HNO4 is there. The structural formula, you can write that structurals. These are the important 5 marks bit. Very simple, you are getting up. So per nitric acid is means the per is means it is having of the a peroxy group is there. This is per. You are having of this one. So how many are over? 3 oxygens are over. 1 hydrogen is nitrogen is. Again you are having of 1 oxygen. Simple. Okay, that will be linked with the, you can't write this is the arrow mark towards the nitrogen as representing. Suppose we won't get the minus this arrow mark. That means there is a nitrogen which is present on this one. They are getting off this one. This is called as a per nitric acid. So these are the very, very important one for the 5 marks question. See, writing of the only 5 words, you will get the 5 marks. So no examiner will cut the marks here. If you are writing the formulas and structural formulas, you will get the full marks only. Now coming to the, this is an important one of the 5 marks question of the oxy acids of the nitrogen. Now coming to the preparation of nitric acid. Preparation of, you are getting of nitric acid preparation. Generally, nitric acid is prepared in the large scale, prepared by the, when the sodium nitrate is the distilled with the sulfuric acid. Large scale nitric acid is prepared. In that case, you are using of the distilled sodium nitrate is passed through the sulfuric acid. Distilled sodium nitrate. Wow, the
Voice is not clear.
NaNO2 is reacted with the
Voice is
sulfuric
not
acid.
clear, sir.
Sarima? Okay. So sodium nitrate is reacted with the sulfuric acid, formation of nitric acid, and sodium bisulfate byproduct is obtained. This is the sodium bisulfate. It is a sulfuric acid which is used in, it is sodium nitrate. When the sodium nitrate, distilled sodium nitrate is passed to the sulfuric acid, you are getting of nitric acid. This is the major. But in our examination, how to prepare nitric acid by Asphalt process? They will ask the question is 10 marks question. How to prepare the nitric acid by the Asphalt process? Asphalt process is very important here. What is Asphalt process? How the Asphalt process is involved in the, what are the mechanisms are involved in this one? In the Asphalt process, we are using of the ammonia is the major raw material. Here in the particular nitric acid, the major raw material is sodium nitrate. See, observe the difference between the ordinary preparation of the nitric acid and Asphalt process. That is a very different is there. So in the Asphalt process, ammonia is oxidized. How the ammonia is oxidized means it is having of the chambers are present. In this catalytic chamber, the catalyst is, we are adding of the catalyst which are using of the particularly main important is the platinum is the catalyst. It is having of the gas, platinum gas sheet is there. Platinum sheet is used in that chamber. So ammonia gas and oxygen gas is passed through the platinum gas. That is a platinum sheet. So ammonia is oxidized. Almost all 95% of the ammonia is oxidized with the oxygen. Formation of nitrous acid. Okay, so nitric, that is a particularly you are getting of the nitric acid is formed in that platinum gas is, that means ammonia is oxidized to the through platinum gas. So in the Asphalt process, you are using of ammonia is important. This ammonia and oxygen is present. The ammonia and oxygen, this is oxidation present. So ammonia is 1 ratio. We are using of one. Oxygens are taken as a 8%. That is a 8 ratio. 1:8 ratio. You are using of that one. Ammonia and oxygen. What is the ratio? Means 1:8%. 8 ratios. They are used in the oxidation process. So in the present, that means the first process ammonia gas is passed through the oxygen in presence of platinum gas. There is a sheet of the platinum gas. You are getting of the nitric acid plus water is revolved. So water will be eliminated out. This nitric acid, that means ammonia, almost all 95% of ammonia is oxidized. Then this particular nitric acid, then it will be passed to the oxidized chamber, again using of the cooling chamber or oxidation chamber. This is called as a cooling chamber. Why? Because here the temperature is very high, temperature is present, almost all 700 to 900 degree temperature will be there. In this temperature, with this particular during of with the help of the platinum catalyst, this ammonia is oxidized into nitric acid. 94% of the ammonia will be oxidized out. This nitric acid again oxidized in the cooling chamber. The partial oxidation here takes place. Only the partial oxidation takes place. We are getting of nitrogen dioxide, NO2 is formed. So immediately in the second step, this is called as a catalytic chamber. It is called as a cooling chamber or oxidizing chamber. The chamber's name is also very important in the Asphalt process. In the Asphalt process, the main important raw material is the ammonia. The ammonia gas is oxidized with the oxygen in presence of the platinum gas, formation of the nitric acid. The ammonia, almost 95% of ammonia is oxidized to formation of nitric acid. This nitric acid is taken into the cooling chamber, or it is called as the oxidized chamber. It will be partial oxidation to formation of nitrogen dioxide and also liberation of some all oxygen. This nitrogen dioxide on hydrolysis, again it is called as the absorption chamber. It is called as a catalytic chamber. Catalytic chamber. Okay. It is called as a cooling chamber. This cooling chamber is also called as oxidized chamber. This cooling chamber also called as oxidation chamber. Okay. Next, nitrogen dioxide, third step, hydrolysis. Means it is called as absorption chamber. This is the absorption chamber. The chamber name is, that means nothing but the cylindrical vessels are there. Three vessels, the three vessels which is called as a, one vessel is consisting of the platinum gauze is there, sheet is there, that is called as a catalytic chamber. Next is the one chamber is consisting of only oxygen is there, that is called as oxidation chamber. Next another chamber is consisting of the water molecule spraying of the water is spraying of, that is called as the absorption chamber. So nitrogen dioxide is reacted with water, formation of the nitric acid HNO3 and also liberated of nitrous, that is a nitric oxide. Next it is a repeat up, it is a continuation process will be taken out. So nitric acid, from this nitric acid, how much the Asphalt process we are getting? Only 68% of the nitric acid. The concentration of nitric acid percentage is only 68 is getting by this method, by the Asphalt process, by the stepwise chambers. We are getting of outlight, that is a product is getting of 68%. This is concentrated, further distilled with the sulfuric acid. Nitric acid is distilled with the sulfuric acid. You are getting of, this is distilled with the sulfuric acid. So you can get 98%. 98% of the nitric acid is, that is the, it is nothing but you are getting of the fumes without colorless fumes are getting. The colorless fumes are getting means it is a concentrated 98%. When you are go to the laboratory, if you are open the nitric acid bottle, that is whatever the lid is opened by the nitric acid, you are getting the fumes, white fumes are coming out. Not white fumes, it's a colorless fumes. That is nothing but the pure concentration of the nitric acid, that is a 98%. Actually, the process of in the Asphalt process, we are getting only 68%. This 68% of the nitric acid is distilled with the sulfuric acid. You will getting of 98. This is called as a concentration. This is about the Asphalt process and general method of nitric acid. So it is a 10 marks question. Please remember very simple one, getting of the 10 marks from this Asphalt process. Okay. The major important is the three steps are important: catalytic chamber, cooling chamber, absorption chamber. This is an important one. By that you can easily understood the concepts and the steps involved in this preparation of the nitric acid by the asphalt process. Now the important 10 marks, one more question is oxy acids of the phosphorus. What are the oxy acids are there? Just now you are using of oxy acids of the nitrogen. Nitrogen is having of only 4 oxy acids: HNO3, hyponitrous, nitrous acid, nitric acid, pernitric acid. Those are 4 are there: HNO, HNO2, HNO3, HNO4. What is the structural formula given? Okay, please take another that particularly practice it. You are getting 5 marks. But particularly oxy acid of phosphorus is we are having of the 6 phosphorus oxy acids are there. The 6 are very important. It is a for 10 marks question. So oxy acids of phosphorus. So oxy acids of the phosphorus, we are using of the phosphorus. These particularly getting of this particular phosphorus, I will use the name of the compound. Okay, molecular formula, and structural formula. Number 1, you are using of, please take down, that is the hypophosphorus acid. Hypophosphorus acid, the name of that one. The hypophosphorus acid, the formula is H3PO2. What is the structure? The structure is very simple one. It is having of one hydroxy group, phosphorus, hydrogen. How many? 3 are present. Okay, 3 hydrogens and also 1 oxygen is over. Next is it is a 1 oxygen which is alone is present on this oxygen. There is a unphosphorus. It is a negative sign. Okay, why? Because it is a only nascent oxygen, means is having of the electron is minus, ion is present. It is a negative sign. Okay, so the oxidation state, this is a +1 oxidation state is there. So the first hypophosphorus acid. Next is the second is phosphorus acid. Next is the phosphorus acid. You can call as a phosphoric acid also. Generally it is called as a phosphoric, H3PO3. H3PO3. The phosphoric acid. I'm cutting off the small things, right? Because the space is very important here. H3PO3. How it is getting off this H3PO3? Just simply H3PO2. Here only 1 more oxygen is present. Okay. So remaining here having of the 3 hydrogens are there, means here getting off this particular structure is very simple one. Here HP. This hydrogen means getting off the OH. The remaining things are same. See the difference between this one and this one. Here H is there. So 1 more oxygen is increases, means we are getting of 1 hydroxy group, 1 hydroxy, 2 hydroxy over. So 2 oxygens are over. 3 oxygen here present. 3 hydrogens. This is the hydrogen. This is a phosphorus acid. Next slide is the hypophosphoric acid. Hypophosphoric acid. Hypophosphoric acid. It is a formula of hypophosphoric acid is H4P2O8. Somewhat difficult, but you have to remember that one. It is actually H4P2. Sorry, not 8. It is a 6. 246, right? Okay, H4P2O6. It is hypophosphoric acid. How the phosphoric acid? This is the formula which is getting off this one. This I can represent as 2 phosphoruses are there. 2 phosphorus which is acting on this particularly. We are having of the 2 hydroxy groups are there. Okay, write down the 2 hydroxy group over, and the next 2 more are there. 2 more hydroxy group. Write on the each phosphorus over. So 4 oxygens are over, 4 hydrogens are over. Next 2 oxygens are there. The 2 oxygens which are present on each oxygen, that is present on the phosphorus. See, Once you understand the concept of that one, you will get the easy to understand the formula, structural formula also. I mean classified here. Okay. So just I'm using of this dark one. Okay. This is about this one. Hypophosphoric acid. Simple. Once you got this particular formula, you can write easily. Next is the fourth one is the orthophosphoric acid. Orthophosphoric acid. What is the orthophosphoric acid? Is nothing but H3PO4. Orthophosphoric acid H3PO4. This is a we are getting off. I can write here. Okay. 3 hydroxy groups is over. Only one oxygen is left. One oxygen like this. Orthophosphoric. But here in this orthophosphoric acid, this is having of the a double bond is present. So there is a negative ion not is present. Only double bond is present on this one because 3 hydroxy. It is an unstable one actually. So the orthophosphoric acid is present of like this. This is next is fifth one is pyrophosphoric acid. Pyrophosphoric acid. The formula of pyrophosphoric acid is H4P2O7. Remember the formula as well as the structure. That is important one. The formula as well as the structure is important. So pyrophosphoric acid. The pyrophosphoric acid is consisting of oxygen. Phosphorus has 2 units are there. Oxygens are 7 are there. So it can write as a peroxy group is present between the phosphorus and phosphorus, and the oxygen means this is OH, 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 OH. So how many are 1, 2, 3, 4, 5 is over. Only 2 are left on this one. The 2 are bonded means it is already it is a orthophosphoric. There is a double bond. It is also double bond is present on the oxygen. This is called as a pyrophosphoric acid. The formula is H4P2O7. Okay. Next is sixth one is metaphosphoric acid. Metaphosphoric acid. See why I'm focusing on this, because it is a 10 marks question. Just to practice it. Write the formula, you can, and write the structural formula. What is the name of that one? Metaphosphoric. Just ask write the oxy acids of the phosphorus. The question is direct question. Write the oxy acids of the phosphorus. Metaphosphoric acid is nothing but the HPO3. It is a metaphosphoric acid. What is the formula? Is a very simple. The formula is, I can write here only HOP. So one O is over. 2 more oxygens. The 2 more oxygens are like this. One is a hydroxy group. One double bond is present. This is a metaphosphoric acid. The structural formula. See, I am not here writing here. I am writing here only. The metaphosphoric acid. This is the formula of that one. Just practice that one. You will get the 10 marks. Why? Because 6 only there. If you are writing the 6, all the 6 with the molecular formula as well as the structural formula, you will get the 6 marks. Okay. This is about the phosphoric. That's the oxy acids of the phosphorus. Next, we will go to the again one more short bit. That is a preparation of superphosphate. Already I told in the first sem also superphosphate. Preparation of the superphosphate. It is repeated in the second sem also for the 5 marks question. How they are prepared there in the first sem superphosphate? The superphosphate, very important raw material is rock phosphate. The rock phosphate means calcium. We are having of the rock phosphate formula is Ca3PO4 second rise. That is a calcium phosphate. This is a rock phosphate. The rock phosphate is crushed into fine powder and mixed with the sulfuric acid. The concentrated sulfuric acid is mixed and keep aside for several days. That means in the dark place we are keeping a fermentation process. Then calcium rock phosphate is reacted with the sulfuric acid, formation of superphosphate. Very simple. What is the use of superphosphate? The superphosphate is used for the fertilizer for the farmers. Why? Because the plant, the growth of the plant, and animals which is used of the phosphorus is very important. Particularly superphosphate is used for the getting of the good yield of the crops. That is purpose the farmers are used for the superphosphate. So preparation of the superphosphate. First, you are important is the what is the formula of superphosphate is asked in the examination for the multiple choice question. So the superphosphate is nothing but CaH2PO4 take one twice plus 2 calcium sulfate. That is a calcium sulfate. Actually, this is a monocalcium hydrogen phosphate. Monocalcium hydrogen phosphate is again with the calcium sulfate. This is a formula of superphosphate. How to prepare means rock phosphate Ca3PO4. This is called as a rock phosphate, generally called as a rock phosphate or called as calcium phosphate. This calcium phosphate is crushed into fine powder and reacted with the concentrated sulfuric acid for several days. You will getting of superphosphate, that is monocalcium hydrogen phosphate plus calcium sulfate. This is called as superphosphate. So I think it is very easy to get the 5 marks. Once you write this question, that means one single step, you will get the 3 to 4 marks. The remaining thing is what is the writing material? Take the raw material of the rock phosphate, crush it into fine powder and add the sulfuric acid and keep it for the several days or 7 to 8 days. That particular calcium rock phosphate is reacted with the sulfuric acid, formation of monocalcium hydrogen phosphate and calcium sulfate. The mixture of the monocalcium phosphate and calcium sulfate is called as a superphosphate. It is a granules type will be there, again crushed into fine powder and export. That means export to the farmers within the form of the powder, that is called as a superphosphate. What is the use of the superphosphate? The getting of the plant, healthy plant. That means the growth of the plant is very good and getting of the good crops. Okay, so among the superphosphate, the phosphorus, very important, the phosphorus is used for the animals also. For the growth of the animals, the phosphorus also required, very important one. Okay, next, this is about the superphosphate preparation for 5 marks question. Next, one more question is called as preparation of hydrazine. Hydrazine. What is the formula of hydrazine? Means N2H4 is a hydrazine formula. So how the hydrazine that is prepared means simple. When the hydrazine is ammonia is reacted with the sodium nitrosyl, NOCl, sodium hypochloride, Na, that means sodium hypochloride. This is sodium hypochloride. When ammonia is reacted with the sodium hypochloride in presence of, that means the high pressure will be there, the formation of N2H4, hydrazine is prepared. The hydrazine and also preparation of the salt and water will be liberated out as a byproduct. This hydrazine is prepared out. Okay. So in the examination, they will ask what is the 5 marks question only, and the multiple choice question, the formula is very important. Hydrazine formula is N2H4. Please remember, preparation will be only ammonia and sodium hypochloride will be reacted with one. We are getting of hydrazine. What is the structure of the hydrazine is also important. The structure of the hydrazine is, we are having of the hydrazine. See, this is the structure of the hydrazine. This is a structure. Very simply to remember. If you want the more, that means the bond angle of this particular hydrazine, this is a 110 degrees. The bond length of nitrogen and oxygen is 1.04 angstroms. Okay, the bond between the nitrogen and nitrogen, the length of the bond length between the nitrogen and nitrogen is 1.47 angstroms. If you want the more information, but don't ask in the examination point of view. If you are, why? Because the numerical numbers you can't remember always. Okay, best only the thing is the structure is important. How it is structured? It is a bonded with the two nitrogen, and these two hydrogens are bonded is one, and this is bonded is one. And here see, this is the bond angle will be 110 degrees. Here also, what is the this one? Same bond angle will be there, but the bond length between the nitrogen is 1.47, but nitrogen hydrogen bond length is 1.047. Okay, so this is about the preparation of hydrogen. And next, one more preparation is there. I can conclude this one chapter. Okay, we'll go to the next block. Next preparation is hydrozoic acid. This is a hydrazine. Next is the hydrozoic acid. Hydrozoic acid. What is the hydrozoic acid means? The formula is HN3. Hydrozoic acid formula is, it is also very important, hydrozoic acid formula. And hydrazine also, what is the just hydrazine, that is N2H4. Hydrozoic acid is HN3, hydrozoic acid. How to prepare this hydrozoic acid means simple. Hydrazine is reacted with the hydrogen, whatever the hydrogen just prepared now. So this hydrogen N2H4 is reacted with the nitrous acid HNO2. This is a nitrous acid. Hydrazine, this is a hydrazine and nitrous acid reacted each other, formation of hydrozoic acid. You are getting the major important is the hydrozoic acid. You are getting of the hydrozoic acid, and also water will be remaining out, that the remaining will be that one. This is a hydrozoic acid. This hydrozoic acid, the formula of hydrozoic acid is a N3 is there. So nitrogens are present like this, and one hydrogen is present. The structure of this particular nitrogen is, that is the present, it is the different bond angle, that is the bond length is there. This is a 1.3 angstrom is there. It is 1.24 angstroms are there. Between the nitrogen, the bond length also it is varies, and also the bond angle here, the nitrogen hydrogen bond angle is 120 degrees, and it is the bond length is 1.101 angstroms are there. Nitrogen hydrogen bond length. See the difference between the nitrogen bond length also differ. Nitrogen hydrogen bond length also differ. The bond angle nitrogen between the hydrogen is 120 degrees. But don't ask, you are having only the structural formula. That means nitrogen, it is a linear one. One is the bedding of the hydrogen. This is called as hydrazine, hydrozoic acid. So this hydrozoic acid, we are getting of that one. So many types of preparation is there. When the sodamide, NaNH2. Sodamide is passing through the nitrous acid, that is the N2O. This is already you are using of sodamide is passing through the nitrous acid, that is N2O, laughing gas. You will getting of hydrozoic acid. That is also one simple phenomenon getting of the hydrozoic acid. But it is a very important is the colorless liquid and explosive in nature. Weak acid. It is an acid, weak acid. HNO3 is a weak acid, but it is a colorless liquid. It is explosive in nature is there. So due to in the laboratory preparation is very dangerous. That's why it is a precautions will be taken to preparing of the hydrozoic acid. So this is about the 5th A group elements. So in the 5th A group elements, mainly important of the, what are the important metal? Nitrogen, phosphorus, arsenic, antimony. In that nitrogen, oxy acid, phosphorus oxy acid, right? Two are very important. Nitrogen oxy acids are 5 marks bit, phosphorus oxy acids are 10 marks bit. Apart from this one preparation is there, nitric acid preparation by Asphalt process. The Asphalt process again the 10 marks. Then you are having of the superphosphate, preparation of the superphosphate, 5 marks bit. Again you are having of the hydrazine, preparation of the hydrazine is the 5 marks, that is the question. And hydrozoic acid. Hydrazine is N2H4, the formula. Hydrozoic acid is HN3, not NH3. So many are writing hydrozoic acid is NH3. It is not, NH3 means it is ammonia. Hydrozoic acid means N3H or HN3. Write this. Okay. N3H or HN3 is called as a hydrozoic acid. This hydrozoic acid is prepared by means of only hydrogen, hydrazine on nitrous acid. Preparation, that means reaction with one, we are getting off the, even though sodium, that is a sodamide also, I will use the one more preparation is there, but not that one. It is a lengthy process with the help of the sodamide and nitrous acid, N2O. Again, you are getting of the byproducts will be getting, preparation will be lengthy processes there, but the best preparation is the hydrozoic acid is this one. This is about the fifth group. That means only one black is over up to now in the tutoring of this one. So next we are having of the classes were 8th, 9th, 10th, 11th, I think so, or 9th, 10th, 11th, 12th. These are, I can complete organic part. 2 blacks are there. Will solidly alkynes are there, aromatic hydrocarbons are there, arenes are there, hydroxy compound, halogen derivatives, and also ethers. Oh, ether is a very small question. Only one question is there. That is a Williamson synthesis. I already told that Williamson synthesis. The simple. That means 5 chapters are major chapters are there. I will complete within the 4 classes. We'll see that one, the 2 blacks, that is a, okay. So here in this today's chapter, please practice only. Only the thing is the practice. Why? Because the formulas are important. You have to practice this. You are getting of the reminding. That is remembering the examination. What is the nitrous acid? What is the nitrogen? There is a phosphoric acid. So what is the boric acid? Like that, the formulas are very important. What is the structural formula? Just practice it. Okay. So we'll leave the class. The next we will meet on the 9th.
Thank you, sir.
Right, Amma.
Thank you, sir.